All right, building on the stuff we did in the last video, we're going to still do adding and subtracting rational expressions, but now we're going to do it with some binomial, trinomial denominators. So it's just a little harder. It still works the same basic way. We'll look at this one. We want to add these two rational expressions together, but they don't have the same denominator. So we need to make them have the same denominator. What I'm going to tell you, again, as always, is factor if you can first. When I look at this question, there's no exponents, there's no common terms or anything. I can't factor, so that's done. Then I need to make it so they have common terms. Just like we did in the last video, we're going to multiply by essentially 1 over 1 to make each one the same. I'm just going to multiply each one by each other's denominator in order to make them have the same denominator. Let's multiply 2x minus 1, 2x minus 1. So when I do this, the denominator for both is going to be the same, 2x minus 1 times x minus 5, 2x minus 1 times x minus 5, which is great because it means I'll be able to combine these together in a sec. The numerators could be a little trickier, 5x, 2x minus 1, and then 3x minus 5. Cool, so those are my new numerators. Now what I'm going to do is I'm going to actually distribute these so that I can see them, and in the same step I'm going to combine these into one giant term. So the giant denominator is still the same. Okay, now they have the same, they're combined together. I'm going to put the minus, and I'm going to put my answers for this in a bracket. The reason this is, well, we'll just do it first, 3x minus 15. The reason this is important is because a lot of students mess up with the negative. This negative actually applies to this entire thing up here. But what a lot of students will do is they'll write minus 3x minus 15 and forget about the second term. The reason I like to write it in brackets like I did here is that then I remember to do distributive property with the negative in the next step, and I get it right, and I won't lose any marks. Up here, this will just become 10x squared minus 5x. So let's actually do the distribution here. So this is going to become minus 3x plus 15. Cool. And now I can simplify. So I'm going to collecting like terms I have. So I'm going to get 10x squared minus 8x plus 15 over 2x minus 1, x minus 5. All right, at this point, I now see that this is a trinomial. I'm going to try and factor it again. The reason I'm going to try and factor it is because I might be able to cancel out with one of these denominators. If that's the case, it'll make my final answer better and more simple, but I can't tell just by looking at it. So I'm going to try and do it. So 10 times 15 is 150. No. I think that's it. Yeah, so I don't see one that's going to add up to negative 8. Yeah, so I don't think that this factors. If it did, if it turned out that it was something like this, I don't know, like if it turned out to be something like that, I could cancel out the two terms that are the same. But because this can't factor, at least not that I see, we just leave it like that as a final answer. But I need to write my MPVs. So x cannot equal, obviously, from here, 5. And from here, 1 over 2. I'm going to look back at earlier steps to see if I missed anything. And I didn't, so that's it. That's done. When we do a little bit trickier one, this one initially you see right away addition and division. So I'm going to use my BEDMAS and know I got to do the division first. So I'm going to rewrite this question, 2x over x plus 3 plus 3x over 2x plus 8 multiplied by... I also should factor if I see anything I can factor, but I don't. I got common factors here and here actually, so let me redo those with the common factors. Cool. I actually now see some stuff I can cancel out. So the x plus 4 is obviously, but then also this x and this x squared just becomes x. That's going to make my life a lot easier. So now when I look at what I got, 2x, x plus 3, plus 3 times 3 is 9, and the numerator, or the denominator is going to be 2x. Cool. So I'm not obviously done yet. Now I got to actually do the addition part. So 2x and x plus 3 don't have anything in common. Some kids might say like, oh, I'm going to cancel these out. Be very careful. You can only cancel stuff out like that when you're doing multiplication, which is what we did before. Here, this is addition. So when we're adding, our goal is to make the denominators the same so we can put them together. So I'm going to multiply each one. This one's going to be x plus 3 over x plus 3. So I have the same denominator. Over here, 2x over 2x. Okay, so this is going to become 4x squared over 2x times x plus 3. Plus, let's do distributive, so we're going to get 9x plus 27 over, again, 2x, x plus 3. Now because they have the same denominator, I'm going to combine them together, so this will all be one giant denominator. So it's going to become 2x, x plus 3. And then the top, I'm just going to write them all out together. And again, if these were the same, if this was a negative, I would have to apply it to everything, but because it's positive, it doesn't change anything, so it's cool. And again, I got a trinomial, so I got to factor it because I might have to be able to reduce over here. So let's go through this process. So 108, the factors of 108. Closer. No. Close. I don't think this one's going to work either. Yeah. So again, yeah, none of these are going to work. They're not going to add up to what we need. So not factorable. Darn. Okay. And this is going to be a final answer. We have to write our NPVs. So x cannot equal from here 0. From here -3. I'm going to check back earlier in the question, which is good because this gave me a different value. This still gave me the 0, and this gave me the -3, which I already had. So that one's going to be, and we had it here as well, -4. -4. Be careful to check back for that other one. There's a lot of times one hidden one that you can't see from something you canceled out. Yeah. So that's our final answer. Sorry, that's our final answer. This is our NPV list, and that's it.